Right now, as we speak, there's a cosmic hunt underway. It's a search for the biggest secret in the entire universe. Scientists are looking for something that makes up the vast majority of, well, everything, but is completely, totally invisible. Today, we're going to join that search.
And that's exactly where our story begins. Deep, deep inside an old gold mine, shielded by the Earth itself, humanity has built the most advanced trap ever designed to catch a ghost.
To really wrap your head around the scale of this mystery, you just have to look at everything. See that tiny little 5% slice of the pie? That's all of it. Every star, every planet, every single galaxy we can see. You, me, all of it. The rest, a whopping 95%, is something else entirely. Something we can't see, can't touch, can't feel.
And if you just look at the mass in the universe, the actual stuff, an incredible 85% of it is just missing. We know it's there. It's the gravitational glue that's holding entire galaxies together, stopping them from flying apart. But we have absolutely no idea what it is. So this is the central crime in our big cosmic detective story. We see its gravitational effects everywhere we look. Those are the fingerprints left at the scene. But the culprit? Nowhere to be found. It's a presence that literally shapes our reality, yet it stays perfectly hidden in the shadow.
So how do you catch a phantom? Well, you build the ultimate ghost trap. And folks, meet our detective, the LUX-ZEPLIN detector, or LZ for short. This is humanity's most sensitive dark matter experiment ever even conceived.
See, if you're going to hunt for a particle that barely interacts with anything, you need silence. And I don't just mean sound, I mean cosmic silence. That's why the LZ detector is housed almost a mile underground in South Dakota. It uses the planet itself as a massive shield against the constant storm of cosmic rays raining down on us from space. And the level of shielding is just extreme. You've got the rock itself blocking all that cosmic radiation. Then it's surrounded by a massive tank of ultra-pure water to stop any stray radiation from the mine walls. Every single component, down to the last screw, is made from special radio-silent materials. And at its very heart, 10 tons of the purest liquid xenon on Earth. That's the bait.
Okay, so who's our prime suspect?
Well, a leading candidate is something called a WIMP, which stands for Weakly Interacting Massive Particle. These things are so elusive, so ghost-like, that billions of them are streaming through your body right this second, and you don't feel a single thing. They're the ultimate cosmic ghosts. So how does this amazing trap actually work? Well, the idea is that if a WIMP, just one of the billions flying through, finally bumps into the nucleus of a xenon atom, it kicks off this tiny, brilliant chain reaction. First, there's a tiny initial flash of light, they call it S1. That little collision also knocks some electrons free. Those electrons are pulled upwards by an electric field into a layer of gas, and bam, they create a second, much brighter flash of light, S2. By measuring the tiny delay between those two flashes, scientists can pinpoint the exact 3D location of the impact inside the tank. It is an absolutely ingenious way to see the invisible. So after years of painstaking construction and calibration in the quietest place on the planet, scientists turned on the LZ detector. They started listening to the universe in a way no one ever has before. The silence was deafening. And after its first 60-day run, the most sensitive dark matter detector ever built found absolutely nothing. Now you might think that's a failure, right? But believe it or not, this is one of the most important results in modern physics. Here's why. Finding nothing actually proves just how unbelievably sensitive the experiment is. This null result has wiped a huge range of possibilities for what dark matter could be right off the map. It tells us our cosmic ghost is even better at hiding than we ever thought, and it forces us to narrow the search and get even more creative. This result is also part of a much bigger picture that's emerging. Our entire understanding of the cosmos, it's shifting. Thanks to incredible new data from instruments like the James Webb Space Telescope, our old standard model of the universe seems to be, well, breaking down. We're now seeing these strange hints that dark energy might not be a constant, and that dark matter might not be a complete recluse after all. And this new data gives us our next big clue in the case. An exciting new theory is that dark matter isn't entirely alone in its invisible world. It might be interacting just ever so slightly with other ghost-like particles we know about called neutrinos. This tiny, subtle interaction could be the very reason our observations of the universe don't quite line up with the old models. The hunt has a fresh lead. So what's the end game here? What happens when we finally catch our culprit? This is about so much more than just adding a new particle to a textbook. Finding dark matter is going to fundamentally change our entire relationship with the universe.
I mean, think about it. Understanding this hidden 85% of the universe would be like discovering a whole new set of physical laws. We could go from just being cosmic spectators to becoming cosmic engineers. If we could learn to interact with dark matter, we might be able to develop things like fuel-less interstellar travel, or build telescopes that use gravity itself as a lens, or even create shadow materials with unimaginable strength. We'd be unlocking the fundamental operating system of reality itself.
And while this all sounds like pure science fiction, it could become science fact faster than you think. This is just a speculative timeline, but it shows how quickly things could progress once we crack that initial cosmic code. It could lead to technologies that today we can barely even imagine. When it comes down to it, this whole quest is about one thing: illumination. The universe that we see, the 5%, it's like the foam on top of a deep, dark, cosmic ocean. The hunt for dark matter is humanity's first real attempt to dive into that ocean and see what's really down there. We're about to turn on the lights. And that leaves us with one last profound question. Once we gain that ability, once we can engineer the universe on this fundamental level, what's our first priority? What's the first thing we should do?